Hello everyone, welcome back to my channel again. Today, let's explore the embedding models together. This video, we're going to, first of all, introduce some of the embedding concepts with the help of large language model and cross-check with online resources. Then, we're going to the coding part to actually try different embedding models, which I chose for simplicity, just some basic models, and we try to visualize all these models results. As you can see here, this is a screenshot of Hugging Face. Hugging Face has published many open source embedding models which you can try, and you can see there are different benchmarks to actually tell you which model is best at which area. So basically, for embedding models, we have word embedding, sentence embedding, and the document embedding. Here I write document embedding as chunk embedding, but it refers to the document embedding method. So basically, from my understanding, different embedding models in the three categories, they serve for different purpose. Mainly differentiate between the context window. For example, if we have one word, we have one sentence or chunk of text, the embedding models actually works differently to generate different outputs. So according to this graph of importance of embedding, I think it touches most of the important area which embedding models are working to improve the different performance of different models, I would say. For example, like in machine learning area, natural language processing area, information retrieval, and knowledge representation. But for now, I think for natural language processing, like the large language models, embeddings are really important for us to find the meaning of a specific token of a text chunk to actually make it numerically representing in the workflow of the large language model. From the beginning, it transfers your prompt into the embedding, and also when it processing the large language model, throughout the model, it does all sorts of calculation. Then the output text was also transformed from a numerical values. So it is very important for natural language processing. This is what we are going to focus on in this project. But for information retrieval, like the search, also for our RAG workflow in large language model, it is also very important. Then, from a different angle, if we focus on the large language model related embeddings, as I said, we can see different types of embedding as I introduced in the beginning. We can see the different application of the embedding models, and also we need to understand how to measure, how to see which large language model, embedding model is best. So there are different scores, and as you can see in the beginning, you can also check the Hugging Face leaderboard to understand which embedding model is best for a certain range of use case, or in general, which one performs better than the other one. Then, if we take a look at the mapping of different models to the different categories, we can see that it is not always 100% separate. Like you see, the GPT embedding model has been linked to both document embedding and word embedding. So for this kind of context or concepts, I think I will try to explore and explain in the future in more detail. At this moment, I do not give a conclusive comment because I still need to learn about it. Now, let's see how these embedding models can work. So basically, with the help of large language model, I refine my code and present you as below. First of all, we install the different dependencies and we import different modules and also the embedding models. The first one is called Spacy. The second one is Universal Sentence Encoder. So the first one will be used to embed the information or transform the individual token to the numerical representation, and the second one is going to transform the sentence text chunk or a specific length of the text chunk to numerical representation. Here I try to get the Google News. For example, I get the news with a topic with AI, and I'm going to compare this news, or I'm going to process this news single word by single word, or sentence by sentence, or chunk by chunk. So basically here, I'm using the package of GNews, which I find it very convenient to do a lot of exploration of the dataset, which is readily stored by Google. So here, I fetch 4 news from the package and for the further analysis. Then, by introducing different functions, we actually vectorize, or in another way, transform different text lengths to numerical representation. As you can see, the first one is to actually embed each token. The second one is to embed each sentence. The last one is to embed different chunk. So after defining these functions, it will make a summary or an all-in-one process more structured. In this part, we are going to visualize different embedding results. So basically, we are going to check how they are represented in numeric field. But pay attention, I'm not using the vectorized visualization. Here we can see after choosing the one article as a sample article, we actually have the embedding numerical values in a 2-dimension graph to visualize the situation here. So like the first one is by each token, you can see the words are quite scattered around the range, but you can see some words are very close, some words are very distant. But to actually understand which words are close or far away, you need to have different ways to measure similarity. The very famous cosine similarity, or I think other distance calculation, could be implemented for you to understand a more exact value of the distance between the different tokens. Then, by stepping into the sentence embedding and text chunk embedding, like this is 100 word chunk, this is 200 word chunk, we can see the text are put into a more bigger chunks, so we can see the scatter plots, the scatter points are less each step ahead. Then after visualizing all the results, I think it's better to cluster the results to have a better visual. So here I actually implement the cluster methodology like a k-means cluster to see how many groups or a certain number of groups, how are they represented in the graph, and to sample some of the grouped words, grouped sentences to see if the models work well. So as you can see, the first one is about the function to apply clustering, and the second one is about visualize the clusters, and there is also the function to sample similar items. And we're going to both show the sample and to visualize the results of the embedding models. Here in the first graph, as you can see, because we are condensing the multi-dimension numerical values to a two-dimension range, you do not observe a very good representation by the cluster, but I want to say that if you choose k-means cluster, you choose other cluster methodology, you are going to have different results. But here you can see some of the clusters, they actually intertwine with each other or intersect with each other. So what does it mean? It means in a two-dimension visualization, it will project the multi-dimension numerical value to the two-dimension visual. So it is inevitable where you cannot capture all the characteristic of all the embedding numerical values. Let's see here some of the examples. Like cluster 2, we have both words and non-words value. And when you check like a move, motto, hunt, for me personally, these words do not make much sense in the same cluster. I would say they are quite distinct, they are quite different. Then if you check cluster 3, fast, break, things, that, too. For me, they are not very obvious to me that this cluster is a good cluster. Then if you check the other one, and is a continuous. For this one, I think more or less it makes sense. Like and is these words do not hold a very important meaning, or I mean in a word space or in a sentence space. So I think they can be grouped together. But as you can see, the understanding of the embedding models, when you sample a certain clusters, some words, or even some sentences, you are going to see some of the understanding of the different model is not very intuitive. So you need to do more tests, do more experiments, and to read the description of each model to understand how it does its job and how it is being implemented in different use cases. Now, when we turn our eyes to the sentence embedding results, of course, they are also clustered into 5 different clusters. As you can see, for example, cluster 1, for me, it seems like these sentences are from the same news piece, because in general, it is step-by-step explaining a central concept or a central idea or central opinion. But as I say, you can examine by yourself to give your subjective opinion based on your understanding to see if this is a good embedding result which lead to such clusters. Then about different text chunks and the cluster representation, I really suggest you to increase the sample size because I only have 4 news from Good Genius package, and as you can see, the data points are not many. So if you want to check in a greater sense, to check if the embedding model could work on a increasing number of the articles of text chunks, you should increase the sample size and try another way to systematically decipher the results. Because if you manually read each of the news, you cannot decipher so many information in a short amount of time. And I believe you cannot, or in general, people do not have much time to check every detail. This, my personal opinion, would say that it is hard to examine a large language model, embedding model by yourself. You always need a systematic way to try to measure the results in a benchmark or in a visualization, and also to refer to like the Hugging Face leader chat and so on to really understand how these models work. Then now let's see what the GPT interprets the results I presented before. For example, like the word embedding results, you can see it comments that the words like model, hunt, move, which could indicate a thing around a significant quote or phrase. Then let's look at the sentence. The sentence embedding, like cluster 1, contains sentences discussing models and their historical context, which seem coherent. So you need to understand in one way or another to see if such cluster resulted from the embedding value makes sense. About the 100-word chunk embedding and 200-word chunk embedding, if you are interested, of course, you can check both the results or with the ChatGPT to better understand the results. Then, since we may visualize the maximum 3D space, I would recommend you to always visualize any result in a 3D space. Either you use 3PCA to actually divide the features into 3 axes, and here, because when I iterate my code, I actually get an error with MB format, so I actually change the results of the 3D representation to a local HTML file. So later, I'm going to share with you. So basically, the code structure is similar. Import library, function to apply PCA. It is a principal component analysis. I think it's very useful. It's like projecting the features of the numerical values to a condensed dimensions, like two dimensions, three dimensions. Then we also set the function to visualize in 3D HTML and eventually write this file in local environment. Of course, you can choose a different directory as you want in the code level, or after you generate the HTML file, you can save it as you like in your folders. Then there is function to cluster the embeddings. Of course, this is similar like we did before, but I want to say that to you, the cluster and the PCA, they are not the same things, so they don't interact with each other. As you can see here, I did some experiment to do PCA 6 principal components, or 3. It is just for my curiosity to check if the code works, but in reality, you don't need to do that. Then we also have the function to sample similar items from the cluster to visualize. And there is also the implementation of the word embedding and the display and the sample to actually call these functions to perform their purpose. As you can see here, this is a screenshot of the 3D representation. Actually, from here, we can see that in a 3D space, actually you can see the difference from the 2D display I shared with you before, because you can see now the clusters are more grouped, better grouped than before. So this is because whenever you increase one dimension, you are going to see additional characteristic. It's like when you look at this group of data from the top surface, let's say, and you view them as a two-dimensional space, some of them are going to overlap. But if you increase the dimension, you're going to see a different result. The same, when you apply the 3D visualization to different embedding results, like the sentence, or even the 100-word chunk, 200-word chunk, you're going to see different results. I really do encourage you to try them and also check the results and make sure that you understand the embedding on the different contextual sequence to better understand if the embedding models work well. And here, as you can see, if we see the two-dimension representation of the data points, it actually gives you a different sense. So I encourage you to do different experiments to actually see for yourself the cluster, the embedding results, and to see if it can help you to improve your model, improve like your processing of the information retrieval or the processing of different steps of large language model. Now let's come back to this graph in the beginning. So in this video, you see that I have introduced some embedding models for different embedding tasks. Then I tried to examine the embedding results, visualize the embedding results, and I would say the choosing of the model or the examination of the model in this video or the contents are only a small group of the every possible models and every possible ways to examine the models. So I really do encourage you to try the different open source models or closed source models as well, and to apply to your use case to see if they can really perform very well. So I wish you like this video. If you have any comments, please leave below the video. If you want to subscribe, please do subscribe. And I wish this is useful for you. If you have any doubt, feel free to leave a comment and we can discuss anytime. So see you next time. Bye bye.